normal random variable. So let me define what is normal random variable. A continuous random variable x, a continuous random variable x is said to have normal distribution with the parameters mu and sigma. So there are two parameters mu and sigma, where minus infinity less than mu less than infinity and sigma will be greater than 0 if the PDF of x is f of x mu sigma is equal to 1 by root 2 pi sigma 1 by root 2 pi into sigma e raised to minus x minus mu all square whole divided by 2 sigma square, where x ranges between minus infinity to infinity. So we have PDF is of the form f of x equal to 1 by root 2 pi sigma e raised to minus x minus mu all square by 2 sigma square, where minus infinity less than x less than infinity. Now we will define what is mean and variance. I am not doing mean and variance. If we calculate, integrate this e of x, we will find that mean must be equal to mu. Okay, so I'm not doing that. Mean of this distribution, that means if we integrate e of x is equal to integral minus infinity to infinity x into f of x dx. This integration is somewhat difficult, so it's not easy. So if we do this, we will get uh, mean as expectation of x is mu. Will not ask for your examination to find mean and variance of standard normal. Okay, normal distribution. And variance, we can find that v of x is equal to sigma square. So if x is a normal random variable, then we write that x follows normal mu sigma, where mu is mean and sigma is standard deviation. Okay. So the computation, if we want to find out or computation of probability of a less than or equal to x less than or equal to b, when x is a normal random variable with parameter mu and sigma. So if x follows normal mu sigma, and if we want to calculate this probability p of a less than or equal to x less than or equal to b, then we have to evaluate this integral. So but evaluating this integral is not easy, and there is no method, that is none of the standard integration techniques can be used to accomplish this. That means we cannot find this integral. So what we will do, to find this probability. So instead, what we will do is, for mu equal to 0, that means if mean is 0 and variance is 1, then this expression, that is 4.4, this expression p of a less than or equal to x less than or equal to b has been calculated using numerical techniques and tabulated for certain values of a and b. That means by using a normal table, we can find uh, this probability if mu equal to 0 and sigma square equal to 1. That is mean 0 and sigma square equal to 1. We can use table to find this probability, but we cannot do integration, because we cannot integrate this function. Okay, so that is the problem. Now this table can also be used to compute probability of any other values of mu and sigma under some consideration. So we have a table, that means table for mu, table for the probability when mu equal to 0 and sigma square is equal to 1, but this can be used for any mu and sigma under some consideration. So I will show you that how to do that, for how to find the probability for different mu and sigma. Okay, so now let me define a new distribution called the standard normal distribution. So the normal distribution, this is same as normal distribution with the parameter mu equal to 0. That means if our mean is equal to 0 and the standard deviation or variance is equal to 1 is called a standard normal distribution. So if mu equal to 0 and variance is equal to 1 or standard deviation is equal to 1, we call that normal distribution is a standard normal distribution. A random variable having standard normal distribution is called a standard normal random variable. So normal distribution mean 0, the standard deviation 1 ആണെങ്കിൽ it's called standard normal distribution. And the PDF is of the form, and we will always denote standard normal distribution by Z, not by X, but by Z. So the PDF of Z, f of x z 0, 1 is, we just replace mu and sigma by 0 and 1, 1 by root 2 pi e raised to minus z square by 2 minus infinity less than z less than infinity. The graph of f of z 0, 1 is called standard normal curve. So the graph of standard normal distribution is called standard normal curve. So it is in between 1 and minus 1. The CDF is of z is equal to p of z less than or equal to small z. That is, p of z less than or equal to small z is equal to integral minus infinity to infinity f of y 0, in which we will denote phi of z. So the cumulative distribution function phi of z is p of z less than or equal to z, which is equal to integral minus infinity to z f of y 0, 1 dy. But we cannot integrate this. Instead, we will use tables. That values are found by using numerical techniques. Okay, so we will use table. So I will give an example of a standard normal table. So this is okay. So this phi of z means p of z less than or equal to small z. If z is this value, this is the standard normal table. So this area, this integral is equal to phi of z, p of z less than or equal to z. Now we will do few problems. Okay. So first problem, let us determine the following standard normal probability. A, if p of z less than or equal to 1.25. So first what we will do is we will draw the curve. So this is a standard normal curve. So first we will, it's symmetric about 0. Okay. And we have given that we have to find out p of z less than or equal to small z. Okay. So that is given by phi of z. So here we have to find out p of z less than or equal to 1.25, which is equal to phi of 1.25, and this somewhere here 1.25, 1.25. So this area we have. So this value we can get from normal table. So I will show you. So 1.25, 1.25. So the table is here. I want to calculate 1.25, that is positive. So that is negative values. So this is positive values. 1.2 is here. Okay, 1.2 is here. I want zero point 0.5. So the probability is like this. So this is P of Z less than or equal to 1.25. 0.8944. 0.8944. Have you got it? 0.8944. So this is the probability. So if you have any doubt, you can ask me. Okay. Now we have to find the second problem. Second one is I have to calculate P of Z greater than 1.25. So P of Z greater than 1.25. Now if you get this problem, then what we will do is first we will draw the figure. Standard normal table is like this. 0 is in the middle. I want to calculate 1.25 is in the positive. 1.25. I want probability greater than 1.25. So this problem. But we will get a probability up to here from the table. So this is actually equal to 1 minus P of Z less than or equal to 1.25. So this probability is actually 1 minus P, which is equal to 1 minus, we already know that this probability, this is from the table, is 0.8944. So the value is 0.8944. 0.8944. So anybody have any doubt? Oh, this is very easy. You can easily find the value from the table. So that is 0.1056. 1056. So similarly we can do, you can, okay, today I will send you the PDF of this table. Okay. Now I have to calculate this. I have to calculate C. So for that, so C, question number C, I have to calculate P of Z less than or equal to minus 1.25. Okay, minus 1.25. So I have, first we will draw the curve. This is very important, normal curve. And given value is minus 1.25. So this is somewhere here. Okay, in the negative axis, 1.25 minus. So I want to calculate this area. So this is actually phi of minus 1.25. So this is equal to, we can use the table. From the table, minus 1.25. So we will take negative. Okay, negative 1.25. So I will take negative 1.25, 1.2. This is 1.2 and I will write 1.25. So this is the value 0.1056. 0.10 0.1056 is the answer. Okay. So now we will do the next problem. C. So okay, C we done. D. I want to calculate this. This is very important. P of minus 0.38 less than Z less than 1.25. So this is equal to. So first I will draw the curve. So minus 0.38 somewhere here, minus 0.38 and 1.25. So this is actually equal to, I will get a probability from here to here. Whole probability I will get, that is P of, I can write P of Z less than or equal to 1.25. Then I want to calculate, subtract this probability minus P of Z less than minus 0.3. Have you got it? So if I want to calculate this probability, I will calculate, I will get the probability up to this, then I will subtract this. So P of Z less than or equal to 1.25 minus P of Z less than minus 0.25. Okay. So from the table, okay, V of Z less than or equal to 1.25, I know that is 0.8944 minus P of Z less than or equal to, from the table 0.38. Okay, so from the table minus 0. Okay, we will go to minus 0.3. I want 8, right? 8, then 7, 8. Point this value, 0.3520. 0.3520. So the answer is 0.3520. So the answer is if you subtract this, you will get 0.5424. Okay, so this is very simple, you know. Now the standard normal table only gives us um, the values for mu equal to 0 and 1. Now we want to find out if for other values of mu and sigma. For that we have, if x is a as normal distribution with mean mu and standard deviation sigma, then z equal to x minus mu by sigma follows tan normal 0 1. That means this z x minus mu sigma is a standard normal distribution. So here x is a normal distribution with mean mu and sigma. Now if I want to calculate p of a less than or equal to x less than or equal to b, it's enough to calculate p of a minus mu by sigma less than or equal to z less than or equal to b minus mu by sigma. So this probability we can find from the table. So any a normal distribution with any mean and sigma can be found from the table by converting in this manner. Okay, so now we will do a problem. So I will do first problem, and you should complete the other solution. So here we have x is a normal random variable that follows normal mean 16.2 and variance mean 16.2 and variance here given variance is 1 point. So mu equal to 16.2 and sigma square is equal to 1.5625. So we want to find out sigma. Sigma equal to square root of 1.5625. If we find the square root, it is equal to 1.25. 1.25. So you can check whether the square root is 1 point. So x follows normal 1.25. Therefore, I can write z equal to x minus mu by sigma follows normal 0, 1. Now I want to calculate this p of first one p of x greater than 16.8. So this is simply p of, I can write x minus mu by sigma. So z x minus mu by sigma, this is greater than 16.8 minus mu by sigma. Okay. So this is equal to p of z greater than 16.8. What is mu? Mu എന്താണ്? 16.2 divided by sigma. Sigma is 1.25. So this is equal to p of z greater than, if we calculate this, I will get 0.48. 0.48. P of z greater than 0.48 is equal to 1 minus P of z less than 0 or equal to 0.48. So what we want to calculate, 0.48 is here. Then we want to calculate this. So what we will do is, this is equal to 1 minus area of this. So this is equal to 1 minus, okay. So I will calculate what is from the table. What is 0.48? 0.48. 0.48. 0.4 is there. Now I am going to 8. 0.6844. 0.6844. 0.6844. So the answer is 0.3156. So similarly, you do all other problems, and this is your homework. I will share the answer key. and you just try to do this problem. And I will share the question on your uh, WhatsApp group. Okay. So if you have any doubt, you can ask me.